Hey guys, I'm back from the grave. What can I say? I'm actually taking a class called Engineering Graphic Design, which is essentially GeoCAD. So I'd be happy to help you with your homework if you help me with mine. So I guess you guys are working on sequences and series. So I got a couple homework problems from Gavin. I'll go through those, but I wanted to give you a little overview of what sequences and series were all about. The main difference between a sequence and a series is that a sequence is just a list of numbers. And then a series is a list of numbers added together. Okay, so if I had something like, let's just say 1, 2, 2, 3, 4, 5, etc. And this could be infinite or it could be finite. It doesn't actually make a difference. This would be a sequence because we're just listing numbers. If I wanted to turn this into a series, it'd be 1 plus 2 plus 3 plus 4 plus 5, etc. All right, so that's really the only difference between sequences and series. Order matters in both of them. Believe it or not, even when you're adding the numbers together, I know that when you're adding, typically order doesn't matter, but when you get to some more advanced, especially in calculus, order actually ends up mattering, believe it or not. So we're going to make sure that we get these in the right order. A group of numbers where order doesn't matter is just a collection of numbers. That's called a set. So if we just had, this collection of numbers here, this set between 1, 2, 3, 4, and 5, and order didn't matter, that would be called just a set. Whereas a sequence is a group of numbers that's ordered in a particular way. So that's the difference there. The typical notation that you're going to see is going to be something like this. A sub n, that's how you would define your, we'll just talk about sequences for now. And all that means is this is sort of the name of your sequence, and then this is the variable that you're going to use to label each term. So let's say we had the sequence. Let me write this over here actually. So we're going to call this sequence A sub n. Actually, let me erase this series here as well. So in this case, n is the term that you're dealing with. So this would be A sub 1, and this would be A sub 2, and this would be A sub 3, A sub 4, etc. And actually, I probably should have written something a little bit more interesting. So if we had something, a sequence like, let's see, maybe 3, 6, 9, 12, etc. Right? Well, this would be A sub 1. This would be A sub 2. This would be A sub 3. This would be A sub 4. Right? So we're going to be. I was looking at the problems. It looks like you're typically starting with A sub 1, although it's not a hard and fast rule. There are some cases where it makes sense to start at A sub 0. A little bit less common to start at A sub 2 and A sub 3, etc. But usually you're going to start A sub 1 to start. But that's not a hard and fast rule. All right. So there are two special types of sequences and series that you'll come across. The one in the first assignment is called an arithmetic series. A-R-E, give me a break. A-R-I-T-H. An arithmetic. And that just means it's a specific type of sequence or series where there's a common difference between the numbers. For example, if I had a series like 2, 4, 6, 8, 10, etc., the difference between these two numbers is 2. The difference between these two numbers is 2. And the difference is 2 as we go along. So this is an arithmetic series because we have a common difference. We're adding 2 each time, right? Likewise, if we had like 1, 3, 5, 7, that would be arithmetic as well. Difference here is 2, the difference here is 2, the difference here is 2, right? An interesting thing about arithmetic series is the reason that they're called arithmetic is that each number is the arithmetic mean, and that's just a fancy way of saying average, is the average of the previous term and the next term. So you might remember that to average two numbers, we're going to add them together and divide by 2. Well, 6 plus 2 is 8. 8 divided by 2 is 4, sure enough. Let's take a look at 6 here. Well, we're going to add 4 and 8. 8 plus 4 is 12. 12 divided by 2 is 6. So 6 is the average of 4 and 8. 8 is the average of 6 and 10, etc. So that's why it's called an arithmetic series, because each term, each a sub n, is the average of the term before it and the term after it. Okay, and then the other type of sequence that you're going to see, and most sequences in series fall under neither of these, but these are special cases that you're going to study, right? So we have a geometric series, geometric, and this has a kind of a similar taste to it, but it's well, obviously a little bit different because they named it something different, right? Geometric means that there's a common multiplier, a common factor between the two, a common ratio, if you will, right? So if we had something like this, 2, 4, 8, let's see, 16, 32, etc. Now, if we're going to test this, now if we're testing to see if it's arithmetic, we're looking at the difference between these terms, or see if there's anything in common. With geometric, we're looking at the ratio between terms. In other words, we would have to multiply a sub 1 by to get a sub 2. Well, here we have to multiply times 2, and here we also have to multiply times 2, and here 8 times 2 is 16, etc. So we're multiplying by 2 to get to the next term in each case. That is the definition of a geometric series, where the ratio, 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2. The ratio of consecutive terms is the same throughout the series. And the reason it's called a geometric series is kind of like the arithmetic mean, where we have the average of the two neighboring terms ends up being this middle term. Well, this is kind of like a super average in a way. So here we're adding the terms together and dividing by 2. Well, in a geometric series, if we want to find the geometric mean of two numbers, instead of adding them and dividing by 2, we would multiply them and take the square root. So we kind of bump everything up by one order, if you will, right? So look what we have here. 2. 2 times 8 is 16, and the square root of 16 is 4. Let's do another one. So 4 times 16, 16 times 4 is 64, and the square root of 64 is in fact 8. That's why this is called a geometric series. So to reiterate, to test to see if a series is arithmetic, you're going to look at the difference between consecutive terms, and if the difference is always the same, that's an arithmetic series. To test to see if a series is geometric, we're going to look at the ratio between two terms. We're going to divide this next term by the first term, then divide the third term by the second term. If we get a common ratio, if we have to multiply by the same amount to get the next term, then we're dealing with a geometric series. Okay, and the last thing I wanted to kind of go over here, and I kind of touched on it a little bit, you have a sub n, and that's how you would define a series. You can, there are really two ways to describe a series. And let's, so we know about the a sub n notation. We kind of went over that. In fact, let me erase some of these real quick. So let's say that, let's just do a simple series. So we'll define a sub n, and then it's going to be, let's just go 10, 20, 30, 40, 50, etc. Okay, so this will be a sub 1, this is a sub 2, a sub 3, a sub 4, and a sub 5. So the first term is 10, the second term is 20, the third term is 30, etc. Right? We can define this one of two ways. We can either think of this, it's called recursively, where we figure out what we have to do to get from one term to the next. In other words, what do we have to do to 10 to get to 20? What do we have to do to 20 to get to 30, etc.? Well, there are lots of ways to get from 10 to 20. We could say, well, we could add 10, we could multiply by 2, we could multiply by 10 and subtract 80. You can do all kinds of fancy things to get from 10 to 20. But that operation has to be the same for each consecutive term, right? So here, if we, let's add 10. So 10 plus 10 is 20. Let's add 10 again. Hey, sure enough, we get to 30. 30 plus 10 is 40. 40 plus 10 is 50, etc. Right? So that's the operation that we have to do to get from one term to the next. That's how you would define it recursively. So this is going to get a little bit notation-y, but once you kind of get used to it, it's not so bad. So what we do is we define the first term. So we're going to say a sub 1 equals 10. So we're just telling you that flat out. And we're going to say to get to the next term, so we're going to say a sub n, so any given term, is going to be the previous term, a sub n minus 1, plus 10. Right? So if we want to find a sub 5, I would take a sub 4, n minus 1, and then add 10 to it. Sure enough, a sub 5 equals a sub 4 plus 10. So we define the first terms, and the first term, sometimes you have to define a couple terms to get your pattern going. But in this case, we just had to define the first term, and then we're going to write an equation that tells us what we have to do to get to the next term. In this case, to get to a given term, we're going to take the previous term and add 10. To get to this term, we take the previous term and add 10, etc. So this is called recursive. Okay, it's a little bit easier to get from one term to the next in this type of situation. It's actually easier to define sequences this way as well. The disadvantage is, okay, we have a series. Well, this is a little bit more obvious, but if you had a sequence that was not quite as obvious as this, well, how would you find a sub 50? Well, we know that a sub 1 is 10. We just add 10 and add 10 again. We're going to have to go through 50 processes to find a sub 50. And if it wasn't so obvious, that would be kind of a pain. So that's why we actually have a second way of, well, it's among other reasons, we have a second way of describing sequences and series. This is the recursive way. And then we can also define them explicitly. And I actually shouldn't have erased all that. I was going to say a sub n. Let's write that series again. It goes 10, 20, 30, 40, 50, etc. This is a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5, etc. Remember, to define something recursively, we would define the first term, and then we figure out what it took to go from the first term to the second term. Okay, so if we're going to define something explicitly, we're going to think of this essentially as a function. Right? So we're going to put these things through the A machine. So we're going to take these numbers, these are our inputs, and we're going to put it through the machine that's going to give us these outputs. It's just like a function, right? Okay, so what do we have to do to 1 to get 10? Well, there are a lot of ways to turn 1 into 10. We could multiply it by 10, we could add 9, we could do all kinds of things, right? But let's do a process that gets 1 to 10 that also takes 2 to 20, that also takes 3 to 30. Well, we could multiply by 10, right? 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30, etc. Right? So now, if we want to give an explicit definition, we don't have to define any of these terms right off the bat. We can just define it in terms of our inputs, right? So a sub n, in this case, whatever n we're given, we multiply it by 10 to get our output, right? So it's going to be 10 times whatever our number is. So a sub 4 would be 10 times 4, sure enough. 10 times 4 is 40, right? So this is an explicit definition, a description of this series. I'm sorry, it's a sequence. If they're added together, it'd be a series. And then, of course, the recursive. We define a sub 1 as 10, and then a sub n equals a sub n minus 1 plus 10, right? So there's two different ways of describing the same, in this case, sequence, and you can do the same thing for a series, right? So we can define the first term, and this is going to tell us what we have to do to get from a term to the next term. Or if we want to define it explicitly, we're treating it just like a function. We're figuring out what's going to take to get make our first term 10, what's it going to take to make our second term 20, etc. We're going to have to multiply our term number, this subscript here, by 10. So a sub n is 10n. Okay, so those are the two ways to define a sequence. All right, so hopefully that helps. I'll just go ahead and dive into the problems now.